Good morning, students. I believe by now every one of you is familiar with what a quadratic equation is all about. So in this lesson, we are going to learn how to solve a quadratic equation by factorization method. And by the end of this tutorial, I expect every one of you to be able to identify the various steps required to solve a quadratic equation by factorization method. Most importantly, know how to solve that quadratic equation by factorization method. So in this lesson, we have only two problems. We have two quadratic equations of different kind. The first one, you can see that the leading coefficient is 1 because x squared here is the leading term. The number attached is always the coefficient. So here is naturally 1, and 1 multiplied by anything is that thing. This is why 1 is missing here. But naturally, we have a 1 here. And the second form is when the leading coefficient is not 1. You see, we have 3 here, which means 1 is not equal to 3. But before we start, it is important to know what this factorization is. Remember, if you have a number like 4, we are talking about factorization. We are talking about factors. But in this case, we mean only two factors. These factors are the values you can multiply together to get that number. For instance, 4 here. What are two numbers you can multiply to get 4? I know once I multiply 1 by 4, this will give me 4. And I know if I multiply negative 1 by negative 4, this will also be equal to 4, right? If I multiply 2 by 2, this will give me 4. Same time, if I multiply negative 2 by negative 2, this will give me 4. So all of these are factors of 4. But we need one pair, that is two numbers you can multiply to get 4. The same thing goes to quadratic equations. Remember, generally, a quadratic equation is of the form ax squared plus bx plus c equal to 0, right? So to factorize this, we want to come up with two factors, which when you multiply them together, you get this quadratic equation back. For example, let's assume that the roots or the solution to the problem are x equal to k and x equal to h. Therefore, the factors of this quadratic equation will be in the form x minus k multiplied by x minus h. If and only if k and h are said to be the solution to the quadratic equation ax squared plus bx plus c. So if you have these two factors, remember they must be equal to 0 if you multiply them together. Why? Remember that the whole of the left-hand side is equal to 0. Therefore, the factors of the left-hand side must also be equal to 0. So since x minus k and x minus h are said to be the factors of this quadratic equation, their product must also be equal to 0. And what does this imply? Remember, if two things are multiplying each other, let me say, if two numbers are multiplying each other and the result is 0, it implies that one of the numbers must be 0 or all of them. Because if I have two numbers like a and b, a multiplied by b equals 0. There is no way a multiplied by b will be equal to 0 if not one of them is 0 or all of them. Because if one of them is 0, for instance, if a is 0, you have 0 multiplied by b, this is 0, right? And if b is 0, we have a multiplied by 0, this is equal to 0. And even if all of them are zeros, we have 0 times 0 to be equal to 0. So since we don't know which of these factors is 0, it implies either of them, either x minus k equal to 0 or x minus h equal to 0. This is what you should know about factoring. So if that is the case, remember that whenever a term crosses over the equality sign, it changes sign. So this is negative. Once it crosses over, it becomes positive. So we have k equal to h. Or if this crosses, oh, this is k, sorry, x equal to k, x equal to k, as negative k crosses over, and we have x equal to h here. This is why I told you we assume that k and h are the roots or the solution to that problem. So how do we apply this principle in factoring quadratic equations? So let me show you. The first one is uh, x squared plus 8x plus 12 equal to 0. To factorize this quadratic equation, remember not all forms of quadratic equations are factorable. This is why we are going to other methods. So if we assume that this quadratic equation is factorable, the first step, I'm not going to write all the steps for you, but as I mentioned, you take note. The first step, you take the leading coefficient. Remember I told you that the coefficient here is naturally equal to 1. So take it aside. You can do the rough work elsewhere. Take that leading coefficient, then you multiply that with the constant term. That term without x is said to be the constant. So we have 12 in this case. So we have 12. So if you multiply these two together, you have 12. Right? This is the first step. The second step, you think of two numbers, which when you multiply them together, you get this 12. The moment you add those two numbers together, you get the coefficient of x. This is x. Its coefficient is 8. So two numbers you can multiply together to get 12. But once you add them together, you get 8. I know the numbers are 2 and 6, but let's assume you cannot quickly think of those numbers. The best way to do that is to list out the factors of 12, numbers that can go into 12 without remainder. Factors, let me write them here. Factors of 12. Numbers that can go into 12 without remainder, we have 1, we have 2, we have 3, we have 4, we have 6, we have 12. All of these numbers can go into 12 without remainder, and they are negative counterparts. So I can do this and say plus or minus. Either it is plus or minus, all of them will go into 12 without remainder. But we need a pair. Two of them you can multiply together to get 12. I know that if I take 1 and 12, I'm going to get 12, right? So 1 times 12. And I know that if I take 2 and 6, that is 2 multiplied by 6, and 3 multiplied by 4. 3 multiplied by 4, including their negative counterparts. Negative 1 times negative 12, negative 1 times negative 2 multiplied by negative 6, negative 3 multiplied by negative 4. All of these combinations will give you 12. But we need that pair that are added up to 8. So let's see. 1 plus 12 is 13, not 8. 2 plus 6 is 8. 3 plus 4 is 7. Negative 1, negative 12 is negative 13. Negative 2, negative 6 is negative 8. Negative 3, negative 4 is negative 7. So this is the only pair that gives what? 8. So this is what we need. So instead, we are going to replace 8x with 2x plus 6x. Can you see the second step? So we repeat, this is x squared, but instead of 8, we write 2x plus 6x. But it doesn't matter, you can write 6 before 2. So we have plus 2x plus 6x, then you repeat 12. This is equal to 0. Now we group them like this in batches. First 2, second 2. Now we are going to factorize this and this separately. What do we have in common between x squared and 2x? What we have in common between the two terms is x, because this contains x, this contains x, and x squared means x times x, remember. So one of x will come outside. Inside, you take x squared, you divide by x. Remember, x squared is the same thing as x times x. If you divide by x, one of the x will cancel, leaving only single x. So if you take x squared, you divide by x, that will be x plus 2x divided by x. The x's will cancel, leaving only 2. You come here, your plus is already there. What do we have in common between these two terms? They only contain a number 6 in common, because 6 can divide 6 and 6 can divide 12 as well. So we bring out 6 inside. 6x divided by 6, the 6 will cancel, leaving x. Plus 12 divided by 6 is equal to what? 2. And this is equal to 0. Now, if you observe, those numbers under the parentheses, or the values under the parentheses, are exactly the same. So we can repeat the factorization again. What do we have in common between the two terms is x plus 2, right? So if you take the whole of x times x plus 2, you divide by this, you're going to be left with x. So naturally, whenever you come to this stage, because this is now the stage number 3, take one of them, then you multiply by this plus this, that is x plus 6, and this is equal to 0. Then we repeat that process, because we have two things multiplying each other and the result is 0, which implies one of them must be equal to 0, or all of them. So we assume all of them are equal to 0. So let's continue to the other side. It implies either x plus 2 equals 0, or this one, x plus 6, is equal to 0. And remember, our main goal is to find the value of x. If you take positive 2 to the other side, it becomes negative. And another way you can do that, you can subtract 2 from both sides, but I prefer to take it to the other side. So once you take 2 to the other side, it becomes negative, which implies x equal to negative 2. You see, one of the solutions. Or if you take 6 to the other side, it becomes negative 6. So you can see that these are the solutions to this problem. And that's what we call a check. A check is that you take those values, you plug them into the original equation to see whether what is on the left hand side is equal to what is on the right hand side. This is what I mean. If you take x equal to negative 2, you come here, negative 2 times negative 2 is 4. Then 8 times negative 2 is negative 16. Then you see 4 minus 16 is negative 12. Negative 12 plus 12 will give us 0. Therefore, since after simplifying the left-hand side, it results to 0, it implies x equal to negative 2 is a solution. You can do the same for this. So this is how to factorize a factorable quadratic equation when the leading coefficient is 1. So now let us look at this situation. So number 2, we are going to repeat the same process. You take the leading coefficient 3, you multiply by the constant term, which is 30. So let's do that here. You don't have to show it in the book. You can do it elsewhere. So 3 multiplied by 30, this is equal to 90. Okay. You have to think of two numbers, which when you multiply them together, you get 90. The moment you add the two numbers together, you get 33. So I think I'm not going to show you all the previous steps, but it remains the same. But one thing you should know is that whenever the product of two numbers gives a positive number, it implies that either those two numbers are all positive or they are all negative. Because negative times negative is positive, positive times positive is also positive. But those two numbers, we want to add them together such that we have a positive number, which implies that those two numbers must be positive. Because let me show you something. Let's assume the numbers are 2 and 3. You know, if you multiply 2 by 3, you're going to get a positive number 6. If you add them together, you're going to get a positive number 5. But let's assume they are all negatives. If you multiply them together, you get a positive number 6. But the moment you add them together, you get a negative number 5. This is what I told you earlier, that those two numbers must be positive because we want their sum to be positive because the product is positive. It doesn't matter, two negative numbers can give you a positive number if you multiply them together. But once you add them together, you must get negative. but this is a positive number. Therefore, those two numbers must be positive. So you can see that we have saved our work for finding negative numbers. We don't want them. We know these two numbers that will give us 90 after multiplication must be positive numbers. All right, so that's number one. Number two, you can list the numbers you can multiply together to get 90, but I'm going to skip that step. I know that there are 3 and 30. If you multiply 3 by 30, you must get 90. And if you add 3 and 30, you must get 33. You can list out the other factors, 1 times 90, you understand. So instead, we are going to replace this with this. So we have 3x squared here plus 3x plus 30x. 3x plus 30x will give us 33x back. So we have plus our constant 30 equals 0. Now we are going to factorize them in batches, first 2 and second 2. What do we have in common here? So this time around, we can see we have numbers and letters. You should relate the numbers separately and letters separately. Between the numbers, we have 3, 3. So they have a common factor of 3. And that's what we call HCF, highest common factor. Always take the highest. All right, we are not done yet. And x squared and x, they have x in common. So you attach x to 3. Then in bracket, you take 3, you divide by 3, that will give you 1. You are done with numbers. X squared divided by x will give you x. Then x times that 1 will give you x again. So the whole of 3x squared divided by 3x will give you x. And if you want to do that practically, 3x squared is the same thing as 3 times x times x. X times x is x squared. X squared times 3 is 3x squared. You divide by 3x. That is 3 multiplied by x. 3 will cancel 3, x will cancel x. We have only a single x, which is this. You do the same thing for this. A number dividing itself is 1, right? So this is 1. Plus, I have missed something. This is supposed to be 30x, sorry. This should be 30x, please. This is one of those mistakes. So they have, I think, 30 in common. So we bring the 30 outside. Inside, 30x divided by 30 is just a single x. X will be left. 30 divided by itself is 1. This is equal to 0. Now you can see that the numbers under the parentheses are exactly the same. You pick 1, then 3x plus 30. 3x plus 30. And this is equal to 0. All right, we repeat the same process. Two numbers multiplying each other, the result is 0. It implies one of them must be 0 or all of them. Okay, so it implies either x plus 1 is equal to 0 or 3x plus 30 is equal to 0. So let's start with the first one. As 1 crosses over, it becomes negative. So from this, you can see that x is equal to negative 1. So this is one of the solutions. And you should remember that whenever you are solving a quadratic equation, you shall expect two solutions. Either they are the same or different, but they must be 2. Why? Because the power is 2. So for solving any kind of equation, you should always consider the exponent, the power. If it is power of 3, you shall expect 3 solutions. So for the second one, which is this, as 30 crosses over, the equality sign becomes negative. So we have 3x to the left equal to negative 30. But since we are looking for x, we are going to divide by 3. Divide by 3. 3 will cancel 3, so we have x equal to, if you divide this by 3, you have negative 10, right? Negative 10. So these are the two solutions we have for this quadratic equation, either negative 1 or negative 10. So let me give you an assignment to try. You have seen the steps required to factorize a quadratic equation. So I want you to apply the same principle or idea to factorize and hence solve the following quadratic equation. x squared, this is very simple one, 2x minus 35 equals 0. Try this. All right. Bye bye for now.